If a1 is greater than b1, a2 is greater than b2, a3 is greater than b3, so on, an is greater than bn, then a1 plus a2 plus a3 plus so on, an is greater than b1 plus b2 plus b3 plus so on, bn. Proof. Here given a1 is greater than b1, so then we get a1 minus b1 is a positive, means greater than 0. Similarly, a2 is greater than b2, then a2 minus b2 is greater than 0. a3 is greater than b3, then a3 minus b3 is greater than 0. So similarly, an is greater than bn, then an minus bn is greater than 0, means these all terms are positive. So adding these all terms, we get a1 minus b1 plus a2 minus b2 plus a3 minus b3, so on, an minus bn is greater than 0. These all terms are positive. If you add these all terms, the result also a positive. So grouping a1 a2 terms and b1 b2 terms, a1 plus a2 plus a3 plus so on, an minus of b1 plus b2 plus b3 plus so on, bn is greater than 0. So this term transpose a1 plus a2 plus a3 plus so on, an is greater than of b1 plus b2 plus b3 plus so on, bn. Okay. Next note. If a1 greater than b1, comma a2 is greater than b2, then a1 minus a2 is greater than b1 minus b2 is not correct. See this example. 5 greater than 3 and 7 greater than 4. So 5 minus 7 is greater than 3 minus 4. 5 minus 7 how much? Minus 2 is greater than minus 1. This is false statement. So a1 greater than b1 and a2 is greater than b2, then a1 minus a2 is greater than b1 minus b2. This is false. This is not correct statements. So in addition that is correct, but in a difference that is false statement. Another property, sixth one. If a1 greater than b1 and greater than 0, a2 greater than b2 greater than 0, a3 greater than b3 greater than 0, so on, an greater than bn greater than 0, then a1 a2 a3 an greater than b1 b2 b3 bn. So a1 greater than b1 greater than 0 means a1 b1 positive, a2 b2 positive, a3 b3 positive, an bn positive, means all terms are positive. So only a1 a2 a3 b1 b2 b3 so on, bn, all terms are positive. So product of first term a1 a2 a3 so on, an is greater than b1 b2 b3 so on, bn. See this example here. 5 greater than 2, 7 greater than 4, 2 greater than 1, then so 5 into 7 into 2 is greater than 2 into 4 into 1, 70 is greater than 8. Note. If a1 greater than b1, a2 is greater than b2, then a1 a2 is greater than b1 b2 is not correct. So what is the difference of both here? a1 b1 a2 b2 all are positive terms. Here not mentioned positive. So if not mentioned positive means a1 b1 terms are either positive or negative, any one. See this example. 5 greater than minus 2, and 2 greater than minus 8, then 5 into 2 is greater than minus 2 into minus 8. 10 greater than 16, this is false statement. So a1 greater than b1, a2 greater than b2, then a1 a2 is greater than b1 b2 is not a correct statement. So next property, if a is greater than b greater than 0 and n is a positive integer, then a to the power of n is greater than b to the power of n and a to the power of 1 by n is greater than b to the power of 1 by n. This is also one of the property. Note, let x is any real number, a comma b are two real numbers, and a less than b, then a less than x less than b. Then what is the solution of this one? If we get like this model, then what is the solution? X values are lies between a and b, but not included a and b. X values are lies between a and b, not included a and b. So x belongs to a comma b with open brackets. Second one, a less than or equal to x less than or equal to b. Then what is the solution? X belongs to, here x values are lies between a and b and included a and b, here not included, here included a and b. So x belongs to a comma b with closed bracket, closed, here open. So next one, x less than a, then x belongs to, so x values are smaller of a, smaller of a smaller of a, so minus infinity comma a. Here a is not included, so that's why open bracket. X less than or equal to a, then x belongs to, here a is included, minus infinity comma a is included. X greater than b, then so x values are more than of b, more than of b, so x belongs to b comma plus infinite. Here b is not included. X is greater than or equal to b, x values are more than of b, then x belongs to b is included plus infinity. Next one, a less than x less than or equal to b. So x values are lies between a and b included, a is not included, so x belongs to a comma b, this is closed. A less than or equal to x less than b, then x belongs to, a is included, b is not included. Okay, these are formulas. So you observe these formulas. You have to solve one problem. Solve x minus 2 into x minus 3 greater than 0. So how to solve this quadratic expression inequalities? So here two quantities are there, so the product of two quantities, when will you get positive greater than 0, means this total term is positive only. So when will you get this total terms are positive, means these both quantities are either positive or either negative. So here we get two cases in solution, we get two cases. First case, case 1, both quantities are positive. Both quantities are positive means x minus 2 is greater than 0 and x minus 3 is greater than 0. X minus 2 greater than 0 means x is greater than 2, and x minus 3 greater than 0 means x greater than 3. Okay, so here x values are more than 2, More than 2 means if you take 3, if you substitute here 3 minus 3 is 0 only. So this term is 0. 0 into something 0. 0 greater than 0, that is not satisfied, means this condition is satisfied. So this is x values is greater than 3 means more than 3 means if you take 4, so this condition is satisfied. 4, 5, 6. So existing this condition only, possible this condition only. So x greater than 3. X greater than 3 means like this model. So what is the solution? X belongs to 3 comma infinite. This is in first case. Second case, both are negative. Both are negative means x minus 2 is less than 0 and x minus 3 is less than 0. X minus 2 less than 0 means x less than 2 and x less than 3. X less than 2. If you take x less than 3, x less than 3 means smaller of 3. X values are smaller of 3. Smaller of 3 means if you take 2, if you substitute here 2, 2 minus 2, 0. So 0 into something 0. 0 greater than 0, that is not correct. That is false statement. So here we get only correct one is x less than 2. Smaller of 2. Smaller of 2 means if you take 1, satisfy this condition. 1. If you take 0 also. Okay. So we get this one. So solution is x belongs to smaller of 2. Smaller of 2 means minus infinity comma 2. This is second one. Okay. So therefore solution, common solution, x belongs to minus infinity comma 2 union 3 comma infinite. Okay.